quite difficult. So people have been thinking about this from very long time, that today the web is made up of HTML, CSS, and JavaScript majorly, and how can we involve more, the other spectrum of the development languages to work on, or to get the web more empowered. And people have been working on these things from a very long time, and this is the first time which came in, which is named as asm.js. This was one of projects started by Mozilla to include other languages on the web. So this is an example where you can see a very simple C++ piece of code, and this is how the asm.js was created with the help of something called mscripter. So right now what you see here is a C++ code, and this is just like this doing something with this array of numbers, and this is being converted into JavaScript. So this was the first attempt to use the known web language on the web. So this is pretty this looks very complex. Let's go to a simpler example. So this is an example where a function is written in C, which is simply incrementing a number by 1. And the asm.js conversion of the same piece of code is written in the bottom box. What is happening here is more or less a normal JavaScript. But if you notice, there are a couple of other things which are happening here. For example, if you see the first line inside the code block, this is doing the operator with 0, which is nothing, it's not really doing anything here. Like I, and then this pipe sign 0 is not really doing anything, but this is making sure that the integer variable is being used here. So it is actually a strict subset of JavaScript. Like this is a JavaScript, but this is slightly different. Like you see these things which are kind of like useless. The 5050, these are useless both the places. But what it does is it is actually doing the operation on the bit level, and which is making it faster because it doesn't have to check for the sign. So here we could have simply done +1 on the input, which is I, but we are doing the pipe sign just to make just to make sure that we are only doing the operation on integer. Otherwise, in JavaScript, whenever you write the plus operator, it works on all the types. Like it will also take in the float type. So if the plus operator is checking, or the plus operator doesn't know what are the operands, it will work by default on float level. Like, okay, even if it is float, I'll be able to take care of it, but the speed or the performance will be slower. So with help of this thing here, asm.js knows that this is only the integer, and even the output is also doing 50, which is also converting it to integer. So now this function is equivalent to the function in C, which is written above it. So you can see in the function written above it, the int is mentioned in the parameter, and also the int is mentioned as the return type. Now, to be able to make sure that even the JavaScript code is also working only on int and not on float, this pipe operator is actually used here. So that's what it is. I'll tell you more about it. First, let's learn about what is mscripton, with the help of which the asm.js was actually created. So mscripton is a tool chain used for compiling to asm.js. Like we can take any language like C, C++, and we can compile it to asm.js. This runs C, C++ code on the web, and this runs as a backend to something called LLVM. For the sake of keeping it simple, I will actually skip the LLVM part, but to give you a gist of it, this is a framework which can be used as overall compiler framework kind of thing. So you can give any front end, like you can give any language to the front end, you can use anything on the for the IR, and you can produce any backend code. So basically this converts things from here to there. We will learn more about it as we go forward. So this is where you will see mscripton being used. So the asm.js works overall this way. You take the C, C++ code and you give it to LLVM. Now LLVM can create any intermediate code and we can give it to mscript run, which then finally produces the asm.js code. So you don't really have to learn more about LLVM and mscript run. For the sake of simplicity, I'll skip that part. But what you learned is we were able to create asm.js from C++. But what is special about asm.js? Like, why are we even using asm.js, or like what is it actually solving? It is a script subset of JavaScript. This is a low-level subset of JavaScript. So you've seen that you cannot simply use the plus operator. You'll also have to use pipe 0 if you are writing the int code. So now this is not the asm.js is not the complete JavaScript, but this is a subset of JavaScript where you can actually see um, you can only use, or sorry, the asm.js will only use the most performant parts of the JavaScript. Since JavaScript is doing a lot of work, we will only take the fast performant uh, things of the JavaScript, and that is what is called as asm.js. So you can write any C++ code, and with the help of this chaining of LLVM to script, and you can create the JavaScript. And that was the first attempt to use non-JavaScript things on the web. So if you have written some piece of code in C language, and if you have written, like, let's say desktop software with the help of that, now you want to create a website, you can do that with the help of asm.js. So the asm.js is again a normal JavaScript. So let's say if you have written a method which is doing a complex calculation in C language, you can convert that method to JavaScript method with help of asm.js, and you can use it on the web. So that was the first attempt. It has the enhanced performance because this is not a normal JavaScript. Like, this is the strict subset of JavaScript which has the enhanced performance because it is using only those parts, and also this is making sure that we are using the good parts of other languages. Let's say if we are coming from C++, it knows the type, but when we are in the JavaScript, it doesn't know the type. I mean, it doesn't know exactly if it is float or if it is integer, because we do not differentiate in JavaScript. So asm.js knows those things. Like, it does hack by some ways to make sure that we are only performing operations there. So that's how it is still hackish. Like, even though we were able to convert things from C++ to asm.js, but this is still hackish. Like, we are doing something in between and making it happen. And the most important problem is this is still limited by JavaScript, what JavaScript can do. So this was all about the first part, which is asm.js, like what it was and how it was being used. If you have any questions, you can type in the live comment section. I'm checking that often. Okay, so till now what we've learned is JavaScript is very powerful these days, and web is doing a lot of things, but JavaScript is not like, Superman kind of thing. Like, it is doing a lot of things, but it is being overused, and there are a lot of things which JavaScript is not really able to do properly. So to be able to do that, people have been thinking about using non-JavaScript languages on the web. And the way they solved it very first was using asm.js. So this was about the asm.js. You can take a look at it again, like how is this diagram actually taking care of converting your things from C++ to asm.js. I'll pause here for a minute just to see if anyone has any questions about asm.js. Okay, let's continue. So now, to be able to do better, what we can actually do is we have to think about how the browser actually works. Like, we have the asm.js, like, or we had the asm.js, but still we wanted a better solution to include other languages on the web. So this is the diagram where you can see the overall, the way a browser works. So if you see the orange section, this is called the JavaScript runtime. And if you see the rest of the part, the browser, so the browser overall has two important parts. One is the the orange box, and second is like the bluish box. So it has the web APIs in the bluish box, which is like, DOM, file storage, and all these things. But internally, just for the JavaScript, we have the JavaScript runtime. So it has the parser, it has the compiler, it has the AIT. what it does it, we give the inline JSS and the external JSS like .js files to the parser. It parses it, then it compiles it, and then it gives it to the JIT just in time. Now the JIT will work with the web API, with the web APIs, and it will finally serve it to the server. So if we have the asm.js that is still going to the parser, and the parser will pass the JavaScript file, and then this is compiling it, and then this is giving it to JIT. Now the another approach or the another solution for the for this was to use or to introduce something at some other level, and if you can figure out, this is where we wanted to attack, or this is where the WebAssembly comes into the picture. So what if we do not actually do something directly on the JavaScript level, and we include the non-JavaScript languages and we feed it directly to the JIT, but we cannot really feed C++ or anything directly to the JIT. And that's where the brainstorming started to happen. So I'll first introduce you what exactly is WebAssembly, and then we'll move forward. So it is a binary executable format for the web. It is not limited by JavaScript capabilities, and it integrates properly with the web. So now let's look at it again. The JavaScript is coming from the it's coming from the inline files like in the HTML or from the JavaScript file, and it is being given to the parser. Now the parser is actually parsing it, and then is compiling, and then is giving it to the JIT file. So there is a binary format which is going to the JIT, which is coming from JavaScript. And then we also have WebAssembly.wasm format. Now this binary format is also going to the JIT. So now the JIT understands two things. One is JavaScript and the other thing is WebAssembly. Both of them will talk to the web APIs, and then this will serve things on the web. So that's where the WebAssembly is coming into the picture. If you have any questions, you can let me know. Okay, so I hope you understood this, that JavaScript is one side and WebAssembly is the other side. Both are going to the JIT, and then they are creating it for the, they are integrating with the web APIs and giving and then finally this will work on the websites. This is very important to understand what the WebAssembly is not. So it is not a new language. This is just a binary format. I'll tell you more about how exactly we can do that. It is not a new language. It's just a compilation target, which means if you have created a language and while you're compiling, you can compile it to one format. Now there is another target you can compile it to. So if you have a C file, if you compile it, you can compile it to .c, or let's say if you have a C++ Java file, you can compile it to .class, or you can also compile it to .wasm, which is the WebAssembly target. So this is just a compilation target, not a new language. You cannot write your code in WebAssembly. You have to write code in your own language, whatever language you want to write, but you can compile it to WebAssembly. And is not really going to kill JavaScript, because you have seen that JavaScript is coming from one side and WebAssembly is coming from the other side. It works with JavaScript for a better web. Okay, so let's see how we can try out JavaScript. So given an example that you are using, let's say a normal C or C++ code, like the way we have mentioned here, what you have to do is you have to download the mscript and SDK from their website, and then you have to run this command emcc hello.c -o hello.html. So this will convert the C language file into HTML language file directly with the help of WASM somewhere inside. And then finally you can run it like, let's say em run no browser --port 8080 dot. So this will run this file and give the output something like this. So the hello world will be printed on the web. I know this doesn't look any fancy, but I just wanted to show you how easy is this. Like, you can simply get it done within minutes. You have to just download the SDK. With the help of SDK's compiler, you can compile any C++ file into directly HTML file, and you can, like, instead of using this, you can simply double click on the HTML file instead of using the third line, and you will open the browser like this. Now, what is happening inside is you have the C, C++, Rust, or any language, you are creating a WASM file. Now that WASM file is being served along with JavaScript to the web. There are HTML and CSS files, but what you have is HTML, CSS, JavaScript, and WebAssembly. So now when you are actually creating your, or while you are actually opening your HTML page, what is happening here? It is getting the JavaScript and this is also getting the WebAssembly file. So both of these files are coming together and being served on the web. So in this example, when hello world is being shown here, the rest of the part is a normal HTML, CSS, JavaScript thing. But the hello world is being printed with the help of the WASM file, which you see here. Okay, so now if you want to, let's say, use the JavaScript APIs, this is just a sample to show here. You can have the WebAssembly. So as I was talking about, in this way, you can actually compile your things. It's a compilation target. So you can compile anything to Java, to WebAssembly. If you have to use the compiled WebAssembly directly inside your code, this is how you can do it. So you can use a file, file script to read the WASM file, and then you can compile that using WebAssembly.compile, and then you can do instantiate, which will create instance, and then from the instance you can do, like, let's say in the last line you can see here instance.exports.add to, and then you can give the inputs here. So this is just an example shown here. If you have a function which adds two files in, let's say, add two numbers in C or C++ or any language, you can compile it to WebAssembly, and then you can import it in JavaScript like this. There is another way. You can directly instantiate it without even compiling. This looks very complicated to many people. So what JavaScript has done is, in Node 12.3.0 and later, they have an experimental WebAssembly module option where you can simply import it as you import any normal JavaScript file. So you import star as example from example.wasm, and then you can just say example.add2. This is as easy as you import any JavaScript module. So the same way we have the JavaScript module, we also have the WASM module. So there is nothing different in the new mode, and that is making it much more easier for people to integrate in their web, like in their website or anywhere. So now if you look at the key features why you should use WebAssembly is, number one, this is efficient. Right? It has the near native performance, which means as you have seen, it is not doing parsing, it is not doing compiling, it is simply being given to the JIT. It is very fast because we do not really have to do all those operations. This is directly going to the JIT, and also the size of the file which is being used is very slow here. The file which is being used is actually very small, because this is the binary format. This is very smaller, so it is like very quick to load and execute because of the smaller file size. It is safe and secure. All the WebAssembly modules are run inside a sandbox, which is like a secure sandbox that makes it very safe to use. And this is definitely making web much more inclusive. Like you can see that you can use any language which is being used there. So you can all the other languages which we see there. Like, let's say if you written something in Python or something, you can actually use the Python in web. And also this is going to be debuggable. Like right now, the debugging feature is kind of like work in progress. I hope everyone, like, I'm not sure about the exact process, but the way you can debug your JavaScript files, like you can put the debugger, and then you can actually see on the runtime like what is the output. You can put console statements. The WebAssembly is also going to be as debuggable, as simple as JavaScript. So this is going to work with JavaScript as simple as how JavaScript is working. So if you have any questions, you can put it in the live comment section about the WebAssembly. So let's see what is the current state of WebAssembly. In April 2015 is when the WebAssembly community group was started. In next year, there was a browser preview available, which all the major browsers implemented on their side. And then in the next year, they released a consensus saying that the MVP is ready, the minimal viable product is ready, and whatever is supported now is never going to be, like it will not be changed. So it is ready for use, and people have started using from that time. Since then till today, they are working on like post MVP features. Like for any other technology, the way it works, it is working today. So this is not something experimental. This is not something new. It is in the market since 2015, 2016, 2017, and today a lot of websites are using it. If you are a JavaScript developer, you can see how, like, if something is written in other languages, you can embed it here. And if you are not a JavaScript developer and if you want something you have written to be used on the web, you can use WebAssembly to be used there. Okay, this is the browser support as of now. You can see all the major browsers are supporting it, and like overall 88.66% support to all the major things. This is even older. I'm sure this is increased a little more now. I would like to talk about WebAssembly's one more upcoming feature is called WebAssembly System Interface. So right now you can see that if you write something on, let's say, any non-web language, like let's say in Rust, if you written something, and then you compile it to WebAssembly, you can use it on the web. But with help of WASI WebAssembly System Interface, they are trying to run the WebAssembly even outside the web. So it has focus on portability and security, of course. That the WebAssembly will be portable to even other places. So this is one of the exciting things I'm looking forward to. So yeah, that's more or less all about what is WebAssembly. I've also created a cheat sheet on GitHub. You can go and see there, like, a couple of things related to JavaScript, related to WebAssembly. And this is my Twitter account, ram_gurumki. You can also drop me email, or you can connect me via other means. You can get the details from the organizers. So that's all about WebAssembly. If you have any questions, you can type it in the live comment section. Yeah, I'll just wait for, like, let's say 2 more minutes for the questions. And so like, just to answer a couple of FAQs or like the questions which I've already received. Where all can we see Java, WebAssembly today? In fact, WebAssembly, like, you see WebAssembly being used on a lot of websites. We don't even know them yet, like, because the performance of this is as easy as what, or like, as simple as a normal JavaScript. We do not really realize that we are using WebAssembly there. So I know a lot of websites which are internally using WebAssembly, including Code Sandbox.io, which we talked about. So yeah, there is, like, I see a very good future of WebAssembly there. And if you are interested to learn about WebAssembly, or to implement anything, yeah, you can try out WebAssembly and just see how it is going. This is being used a lot in gaming sectors. This is being used a lot in, like, let's say, where you want to show hard graphics related stuff there. So yeah, there are good use cases of WebAssembly, although there's not really that much mainstream as of now. People are not using it that way, but still, I'm excited to look forward for more usage of WebAssembly in the web ecosystem in general going forward. Okay, guys. So thank you very much for listening to this talk. You can reach out to me for any questions, and I'll close this with the note that open source is really very interesting place, and you must learn about open source, and you must contribute to open source world. So if you have any questions, or if you want to know anything about the open source, You can get in touch with me or even the organizer club. They are doing great work on the open source. So please do contribute, or please do check out the open source ecosystem. Especially, I see um, a lot of audience for today's talk are college students. I was involved with Mozilla, like I got involved in Mozilla the time I was in my college, and I'm really fortunate and like I feel really good about it that I was involved that early. So I would encourage you all as well to, find some open source projects and start contributing there. This is going to give you a good exposure to what's happening in the industry and what are the things being used outside, and this is going to add a lot of values to your resume when you are going for the interviews or when you are going for the job, or even if not job, even if you have your own company, or let's say if you are working on some freelance projects or whatever it is, your profile is going to matter, and your profile will shine more if you have open source contributions and such links available your site. So um, go ahead and give it back to the community, and yeah, all the best for your sessions and other sessions and your studies. Stay home, stay safe. Thank you very much.